Welcome you all to virtual instrumentation tutorial. So myself Koti Prakash, MTech Embedded Systems from VIT University. So my topic is data types in LabVIEW. Let's we talk about what is data types in general. Data type is a collection of identifying one of various types of data such as real, integer, boolean. So data types is a very important part in all programming languages. So likewise, in LabVIEW also it is important part. So data types indicates what objects, inputs and outputs you can wire together. So for example, if if you take a meter input, so meter is a input knob present in a front panel of LabVIEW. So meter has a orange border, so you can wire meter to any input with orange label. However, you cannot wire orange meter to an input with a green label. So if you try to wire, then you will find a broken wire. That is nothing but collision, which is an error in LabVIEW. So we can discuss deeper later in previous slides. So these are the various data types present in LabVIEW: numeric data type, boolean data type, string data type, dynamic data type, and cluster, sorry, and arrays. So numeric data type is nothing but it contains either integer or floating point. So integer data types all are represented in blue color, and floating points all are represented in orange color. So then coming to boolean, this type contains a logical combination of true, false, then logical gates and universal gates. Then coming to string, it contains only alphanumeric characters, so it is represented pink color. Then coming to dynamic data type, so this is nothing but a data with associated with a signal and attributes that provide information about the signal. So we will get information provided about the signal, such as the name of the signal, date and time that was acquired. So cluster is opposite of arrays. So arrays, as we know, arrays are of similar data types, but cluster is from several data types. It can be formed with several data types. So cluster data types appear brown if all elements in clusters are numeric, or pink if all elements in the clusters are different data types. So if a cluster is a blue brown color, then in the cluster, all the values are numeric. If it appears pink, then then it is said to be all the elements in that particular clusters are different. So I mean, these are data types can be either scalar, one dimensional array, or two dimensional array form. So um, these are the various types of various data types with a scalar, 1D array and 2D array and cluster. So this slide is nothing but the color representations of each numeric or each data type. So just go through this slide, you will get to know about and how to use these in LabVIEW environment. So coming to numeric data type, so as we said before, integers, floating point numbers and complex numbers. So we know integers is represented as whole numbers. So in integers there are two types, signed integer and unsigned integers. So unsigned integers can be positive or negative, but signed integers can be positive or negative, but unsigned integers can be only always positive. So coming to floating point numbers are represented fractional numbers. In LabVIEW, floating point numbers are represented with color orange. So for example, 9.25, 4.25, 1 by 3, 2 by 3. So all these values are floating point numbers. Then complex numbers. So complex numbers are represented by two values linked together in one memory. So this we know, in complex number there is a real part and imaginary part. So this is the color representation of a numeric data type. For scalar, it will be a single line. For 1D array, it will be a thick line. For 2D array, two parallel lines with based on color. Orange is for floating point, and in the integer blue color. So then, so these, as I said, there are two types of numbers: signed integers and unsigned integers. So in signed integers and unsigned integers, so we can see um, we can see byte, word, long. So these three are the representation of bits. So byte contains 8-bit, word contains 16-bit, and long contains 32-bit. So all these are range according to their respective sizes. So these are all the various functions involved in the numeric data type. So I mean integers to integers, then floating point, then complex numbers. So when we are using a floating point, I mean more precision, then we should use a single precision floating point. So it can be minimum positive numbers ranges from 1.48 to 45. So maximum will be 3.408 plus 38. So based on these values and parameters, you can use in your lab view environment. So numeric conversion is nothing but so consider the just look at the block diagram below. Um, so double point the numeric um, is one input to multiplication, and the IS32 is starting with 32-bit numeric, which gives to another end of multiplier. So we will get a output of result. So I mean both numeric we can just use different colors, but with different data types only we can't implement this one. So we'll get a error. So let's see, when different representation types are wired to the input of the function, the function returns an output in larger or wider format. The lab chooses the representation that uses more bits. The function force the smaller representation to larger representation before execution, and the lab places a force dot on the terminal when the conversion takes place. So the next slide is Boolean data type. So Boolean data type is a true, false, or logic gates function. So in Boolean also we have three arrays: scalar, 1D array, 2D array. So and you can see the representation of control and indicator and type of colors. So just go to this slide. So in LabVIEW, Boolean data has a 8-bit values. If a 8-bit value is 0, the Boolean value is false. If non-zero value represents true. Then Boolean value also have a mechanical action associated with them. The two major actions are latch and switch. Latch action is similar to a doorbell, whereas switch action is similar to a light switch. So latch action is nothing, I mean similar to a doorbell, and the switch action is nothing, I mean similar to a light switch. So you can also define when the switch or the latch occurs, when pressed, when released, and until released. So these are the three various properties. So we will just get through deeper in next slide. So these are the Boolean properties as we discussed in previous slide. A switch when when pressed, when released, until released, like latch when pressed, when released, until released. So these are the various functions. So the name itself tells the meaning. Switch when pressed. So only when we press the switch, the state will change from one state to another. Switch when released, only when we release the switch, the state will change from one place to another. So you can get this by right click the boolean icon and go to properties. So operation tab, you can go to all these files. Then coming to string data type, so string data type is nothing but alphanumeric. Only we can type alphabets. So it is so all. I mean, see the color representation. It is a pink color. So we can see the display types, various display types: normal display, V code display, password display, and hex display. So normal display is nothing but the display printable character using the front of the control, and non-displayable character generally appears as a boxes. So messages, there are four display types. So we can just give the messages as it is in normal display. So in password display, the in password display, as you all know, we can't be able to see the password what we are typing. We instead we will just we just I mean only asterisk symbols are visible. So based on all these things are predefined in a lab environment. So it is very easy to use all these functions when implementing in a complex level. So as we had a glimpse about the cluster data type, now we will see the representation of a control input and the indicator. So these are the symbols so which is enclosed. So as we said, the brown color indicates numeric data type, and pink color indicates the several data types in a particular cluster. Then while coming to second row, so waveform. So when cluster is connected to a waveform indicator, then we will find the respective icon in the LabVIEW block diagram. So dynamic data type. So coming to dynamic data type, the signals are generated or acquired by an Express VI. So Express VI is a tool which is found in block diagram and function palette. So data associated with a signal, that attribute that provide information about the signal, such as the name of the signal or data and date and time that the data was acquired. So we can just get to know when the data was acquired. So it might be 2 years back, 3 years back. So if we go directly to this dynamic data type, so we can get all those information. So you can write the dynamic data type to any indicator or input that accepts a numeric waveform or the boolean data. Use the convert from dynamic data express VI to convert the dynamic data to numeric waveform array data types for use this other VIs and functions. So you can use in different VI platforms. So coming to input data type inputs. So just go to this slide. You will just know which type of input gives um, the different output. So if you are giving both scalar inputs, then you will obviously get a scalar output. When you give different array types, then consider the array of clusters and clusters. You will get an output of array of clusters. So similarly for the boolean data type and cluster data type, so if you give a boolean scalar and the boolean cluster, you will get output as a boolean cluster. So array of clusters as a one input and clusters as second input. So you will find the so array of clusters. So okay, coming to next slide, it is nothing but the representations. So we have various representations. I mean, first I will tell how to reach representation. So just go to block diagram of LabVIEW, then representation, and choose the desired representation. So representation is nothing but it is another property of numeric data type, is the type of representation they use. So in numeric data type, as we said, we have an integers, floating point numbers, and complex numbers. So each type has a unique characteristics. For example, consider consider those images on right side. And these images, so first one is nothing but the extended precision floating point, so then double precision floating point. So these all the things, when we are using a floating point, so double digit is point, I mean 9.25. So it will just round the number which we are given. If you give 18.2586, then it will just down, and it will give the correct value. So likewise, we have a different, so when you come to integer type, there are four types: byte, word, long, quad. So byte is with 8-bit, word is with 16-bit, long is 32-bit, and quad is 64-bit. So then, both for the unsigned and assigned integers we have. And for complex, we have three types of representations: complex extended, complex double, and complex single. Okay, so next, till now we saw the just a theoretical part. We will just go into lab view environment, and we will just work a few data types functions. So yeah, just these are the in data types. So this is first integer data type, floating data type, and boolean data type, and this is string. Then I have rest of a few indicators. So just see the block diagram. I have all connected to an indicator. So control is connected to indicator. So first we will type a number. We'll just give an input as 7, and then floating point as 9.25. Then this is boolean switch I kept on. Then coming to string, just type hello. So while you're executing, you will just find the output in respective indicators. So while coming to block diagram, so these all the data types which is present. So if you want to know about this, just go to show context, which is in right side. Then you can see the what type of data. Then you can just even see the wire, I mean what type of wire, long 32-bit integer. Then this floating point is double 64-bit integer. So coming to next, so then you okay, now if you try to wire, if you try to wire integer, orange label to a blue label, then you will find the red color. That is nothing but the correlation now. So you will find the red color. So when you try to implement, as I said before, you will find the broken wire. So this broken wire, so it is error. We can't uh, we can't wire different colors. So blue to orange, I mean blue to string, different data types. I said you can just wire with similar data type, but you can't wire with different data types. So this is list of errors icon. So you can just go to it, and you can see what errors are you had acquired. So just go to that particular error and just click this. So you will directly I mean you are directly pointed to where the error is. So and okay, actually some problem is coming. So so now you can actually integer value, you can just give an input to string only with operation, number to string operation. Now you can just get the number to string operation in function palette, in string palette. So you can just give, then just see the, now I have connected the integer input to a string by using number to string. Okay, now you can check the output. It is 7 now. So you can see that in integer, we are just giving the output as 7. Okay, okay. Thank you. So, hope you would have gained few knowledge about what is, I mean, what plays on what are the types in data types in lab environment. So, thanking you.